Welcome along to some 3D shape maths, the last one of the week. We're going to have a look at some today which include nets. We're going to have a look at other problems as well which include volume. So let's have a little bit of our work the way through. Again with these, don't feel like anything has to be printed out. Be creative with how you're putting your answers down, whether you're drawing out the nets, whether you're reproducing it, whether you're just having a discussion with someone to work out the answer. All of those are absolutely fine. You don't have to print or resource these worksheets at all. Okay, question number one. These nets will fold to make 3D shapes. Match each net to the name of its shape. One has been done for you. We're going to need to use our knowledge of shape properties. We're going to need to use our visualization ability as well to have a look at this. So what have we got? We've got then, let's have a little run through our shapes. We've got our square-based pyramid. We have a triangular prism. We have a cube. We have a square. And we have a tetrahedron and a cuboid. Now we'll have 1, 2, 3, 4, 5, 6 here, and I've got 1, 2, 3 nets. Okay, so of my 1, 2, 3, 4, 5, which I still have to match, I only have 3 here. Okay, which means that 2 of them are not going to be correct. So it means we can discount some of them. One of them you should be able to discount immediately, because it's not a 3D shape. Okay, so we have a cube, a cuboid, a triangular prism, and a square-based pyramid. Okay, so let's use what we know about these shapes. Let's have a look at this one. We have here, let's count them, 1, 2, 3, 4 rectangular faces and 2 square faces. We've got 6 faces in total. That is going to give us like a rectangular box shape. That we know is called a cuboid, so that one can go there. Thank you very much. Okie doke. So we've dealt with one. We've got 2 left. Here we have a square face, and then we have 4 triangular faces here. If you imagine this, visualize this, fold these up, that's going to give you that pyramid shape. And here we have our square-based pyramid. We know it's a square because the base of it is a square, hence the name square-based pyramid. And then our last one, we have one more net, and we have to choose between a triangular prism and a cube. Straightforward. There's no triangles. It's not going to be a triangular prism. Thank you very much. Question number 2. We have a person here thinking of a 3D shape. It has a square base. It has 4 other faces which are triangles. What is the name of the 3D shape? We've just seen that. So if I was stuck with this, if I, for example, hadn't seen the previous question, what I'd probably just do is I'd probably just draw myself out something like that and think, okay, well, if I've got that, and I know it's a 3D net, so they're going to have to be joined, so they're going to have to, hang on a sec, if it goes like this, it's going to be a, yeah, you guessed it, it's going to be a square-based pyramid. Happy days. Okay, question number 3, complete the table. We have faces, vertices, and edges. Again, sort of continuing from that work we looked at yesterday with them. My 3 shapes, I have a cuboid, a triangular prism, and a square-based pyramid. That's a popular shape today. So if I'm thinking about those, what I'd probably want to do is I'd probably want to very quickly sort of sketch out those shapes. If I was doing this on paper, if I was working like that, I'd probably sketch them out. So cuboid, easy way to sketch out cuboid, you give yourself a couple of squares and then you simply join the corners up. Okay, and if you can't remember the properties of that, if you just do that, that'll help you out with that. Okay, so then from there you'll be able to see, okay, I've got 1, 2, 3, 4, 5, 6, 7, 8 vertices, and actually if I count that up again, I've got 12 edges. Oh, never quite puts, there we go, the numbers exactly where I want them. Okay, so then triangular prism, easy way to draw a triangular prism. Again, any easy way to draw any prism really is you draw the 2 end shapes first of all. So you draw the end faces, triangle, triangle, and then it's a simple game of dot to dot. Join the corners up with straight lines. There we go. Oh, that one's sort of hidden under itself, wasn't the best position, but there you go, you get the idea. From there, I can then work out the number of faces. Well, I've got 2 triangular faces on either end. I've got 3 rectangular faces to make up the rest of my prism. So that's going to give me 5 faces in total. Vertices already been filled in for me. Number of edges the same again here. So I've got 1, 2, 3. Same on the other side, 6, and then 3 round. So I have 9 edges for my triangular prism. For a square-based pyramid, slightly harder to draw. You will need, if you think about it, well, you're going to need your triangular shape there, and then it's going to go a little bit like that, and then you're going to have some form of like lightly dotted line. Let's do that. Let's be a bit clever with that. Lightly dotted line going up the inside and like that and like that. There you go. Not a great one, but you get the idea. So again, that sort of drawing out of the shape is really helpful there, because it helps me work out if I just want to double check, if I want to count that. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, correct. 8 edges. Okay, vertices. 1, 2, 3, 4, 5. And again, what I'll be doing is I'll probably just be marking those off. We always have time in these papers because we work quickly. We get our work finished. It's about this level of precision really to help us make sure we're being super accurate with it. So we've got 5 vertices, and then number of faces the same again. 1, 2, 3, 4, 5. 5 faces. Okay. Happy days. Question number 4. Jack. Shout out to Jack. Jack says we have 2 3D shapes with the same number of faces as each other. They will also have the same number of vertices as each other. Is Jack correct? Yes or no? Unfortunately, Jack, in this occasion, you are not correct. No, you are not. With these questions, rather than writing a huge wordy example, kind of the best option here is just to write some facts down and to kind of prove it. So if we have a think about that, actually if I go back a page, I'm going to pinch 2 of my shapes from down here. Let's see if I can do this. I don't know if I can. No, in fact, let's not do that. Let's have, I'll draw them again quickly, that's fine. Let's have ourselves a triangular, square-based pyramid, sorry. I'm trying to talk and do this at the same time. Not great. So let's have one of these, pop this in here like that. Lovely. It's a bit of a better one. Oh, I'm missing a line. There. So we've got one of these. Now, number of faces here is 5. We know that from the previous question. If I pop in here a triangular prism, let's go for the solid line first of all, please. If I put one of these in here, like so, this becomes the simplest proof that Jack is wrong. Okay, I've got here a shape with 5 faces and 5 vertices. I have here a shape with 5 faces and 6 vertices. So all I would need to write here is, let's go for he, make that a bit smaller. He is wrong. A triangular, I'll spell that wrong. Triangular prism has 6 vertices and 5 faces. A square-based pyramid has 5 faces and 5 vertices. There you go. See, that's all you need to write, is you just need to write down the facts, and then you're done. You're wrong. Triangular prism has 6 vertices, 5 faces. Square-based pyramid has 5 faces, 5 vertices. This completely counter to what he says. So you're wrong, Jack. Apologies. Number 5, Ben. Shout out to Ben. Ben fits a square-based pyramid exactly on top of a cube. These questions are important with the language they use. Exactly means there's no overlap. It means there's no extra faces, extra edges, anything else created. It means where the edges meet, the edges meet. So that's important to know. It's important to identify the language they use. It says to write in the missing numbers to describe Ben's new shape. Okay, well, let's look at faces first of all. I know here that my cube originally would have had 6 faces. I know that my square-based pyramid would have had 5 faces, so putting those together would have given me 11. However, it's not the case because 2 of them are hidden, aren't they now? So I've got 4 on the top here, and I've got 5 for my cube, which means actually my new shape has 9 faces. That's why you need to be a little bit careful with that, so you're not just counting the face of those individual shapes because they've been put together. Vertices. Well, we know that we have 8 on our cube to start with. That doesn't change because I'm still going to have those. Then I've got 1 more because I've got my 9th vertices at the top of my square-based pyramid now, which is at the top. It's like the apex point of our shape. And the number of edges. So I would have had 12 edges on my cube. That's still kind of the case. And then I've just got these extra 4 around here. So that's going to give me 16 edges in total for my new shape. There you go, Ben. Question number 6. This is a net of a cube. What is the volume of a cube? Okay, well, if we think about volume, volume equals length times width. I'll make so it's 1 times height. Okay. However, this is a net. Now, the fact that we know it's a cube is important because if it's a cube, it means if I work out one dimension of length, width, or height, it's going to be the same for whatever else, for every other measurement in this shape. Now, this is an important fact here. This 20 centimeters here, that's 20 centimeters for the whole net, not 20 centimeters for each square face. So what I need to do is I need to work out, actually I've got 1, 2, 3, 4 faces here, and in total that's 20 centimeters. That means that each face is going to be 5 centimeters long. Each edge, sorry, on each face is going to be 5 centimeters long. It's a cube, so it's a cube number. So I could do 5 times 5 times 5, but if I know my cube numbers, I know that that's going to be 125 centimeters cubed. And you can see here again, as we've discussed previously, that unit of measure here is key. It's been put in cubed because that is, as we will remember, centimeters times centimeters times centimeters. Okay, and anything times itself is always going to be cubed. If it was meters as a measurement, it'd be meters cubed. If it was kilometers, it'd be kilometers cubed. If it was millimeters, it'd be millimeters cubed, etc. Okay. Question number 7. Emma, shout out to Emma. Oh, I don't have any Emmas in the class this year. Emma makes a cuboid using 12 cubes. We can see that here we've got 4 cubes on the bottom, 2 by 2, and then 3 high. So this bottom layer, you can see it on the top actually, is 4, and then there's another 4 in the middle, and there's another 4, 4, 8, 12. So she's used 12 cubes. So you need to write the letter of the cuboid that has a different volume, okay? This one is as straightforward as counting. This is a counting question. You just essentially need to work out what the dimensions of this are. If we look at A, it's 2 wide by 1, 2, 3, 4, 5, 6 down. 2 times 6 is 12. That's fine. That uses 12 cubes. It has the same volume as Emma's cuboid. B, 2 across, 1, 2 by 1, 2, 3, 4, 5, 6 along by 1 high. 2 times 6 times 1 is 12. Okay, so that has the same volume. C is 1, 2, 3 by 1, 2, 3 by 1, 2. So it's 3 times 3, 9 times 2, 18. So C here has a volume of 18 cubes. Okay, and that is different to Emma's. So that's the one we think it is. To double check that, we're just going to work out the volume of D and E. If you look at D, it's Emma's, but just kind of be knocked down. Okay, it's 3 by 2 by 2. So 3 times 2 is 6 times 2 is 12. So that one's fine. And then E here, we have 1 cube wide by 1 cube high. So it's 1 times 1, which is 1, multiplied by 12 long. 1 times 1 times 12 is 12. So here again, we have our shape with a volume of 12. So C is the odd one out. Number 8. The shape is made from wooden centimetre cubes. Lovely. How many more centimetre cubes are needed to make it into a solid cube? 3 centimetres tall, 5 centimetres long, and 5 centimetres wide. Now, those are the dimensions we've got here. So your job actually is just to work out what's missing, what's been taken away. There's a couple of ways of doing this. One, you can just simply count, but that's time consuming. It's not an efficient way of doing it. 2, I can use just a bit of number knowledge here. So I'm going to have 1, 2, 3 missing here, same here. So I'm going to have an extra 6. I'm just going to park that number up here because I'm going to need to remember that in the end. Oh, don't want to move that. You're going to put that over there. Now here, if I kind of imagine what's missing from my cube here, I can count that dimension, which is 1, 2, 3, 4 cubes. I can count this dimension, which is another 4 cubes along here, and I can count my height dimension, which is another 2. That essentially means I'm missing a shape from this. I'm missing a big cuboid in the middle here, which is 4 cubes width, 4 cubes length, and 2 cubes high. Okay, so that's going to give me 4 times 4, which is 16, multiplied by 2, which is a 32. Okay, so that's going to give me my missing chunk from the middle. Then I've got an extra 6, which are these ones along the side. Put those together and give myself an answer of 38 cubes I needed. Cleo, hiya Cleo, shout out to you, has 24 centimeters cubes. She uses all 24 cubes to make a cuboid with dimensions 6 centimeters and 2 centimeters and 2 centimeters. Write the dimensions of a different cuboid she can make using all 24 cubes. Okay, you might be able to find various different versions of these. I haven't checked the answers, but there should be that included. The most straightforward one is going to be a little bit like this one here for E. When we looked at Emma's cuboid, she used 12 cubes. She did a 1 by 1 by 12, straightforward. So here you could just have 1 centimetre by 1 centimetre by 24 centimetres. It's going to be your most straightforward one, because 1 multiplied by 1 is 1, multiplied by 24 is 24. So whatever you do for these dimensions, you have to get the answer of 24. When you get a question like this, I would always go for the most straightforward, the most simple, the easiest one, and just sort of guarantee those marks with your answer. John has got 20 centimetre cubes. He wants to make a cube, important word, he wants to make a cube with edges that are 3 centimetres long. We know from work that we've looked at a cube, all edges are the same length, which means that his cube is going to be 3 centimetres by 3 centimetres by 3 centimetres. So he's going to have a cube which is 3 centimetres by 3 centimetres by 3 centimetres. Okay, and he's going to be creating that cube, so length, width, height, etc. Did I just say height? That's not a word, is it? Like that. And if you imagine that, kind of what we're asking here is what is 3 cubed? 3 times 3 is 9, times 3 is 27. We should know that 3 cubed is 27. He has 20 cubes. He needs 7 more, doesn't he? Because he needs to make a cubed number. Okay, 3 by 3 by 3 is 27. He only has 20. He's missing 7. 10 is an open top box. Put a tick for each diagram if it is a net for the box, but a cross if it is not. The base is shaded in each one. Fairly straightforward for this one. Again, that visualization technique of folding up. What you're looking for is you're looking for faces that would overlap or nets that would give you an incorrect one. This is an interesting one. We've got kind of 4 boxes here. It's interesting because there are 3 that are correct, and often people think, oh, there only needs to be 2 correct for this. There's going to be 2 right, 2 wrong. No, there's no pattern, there's no tricks with this. If it's right, it's right. So with this one, these are going to fold up to make the side, these are going to fold up to make the side, this is going to make the end, this is going to make the end. A is correct. Okay, B, this is going to fold up to make the end. This is going to come to be this side here. These are going to fold up to make the sides. This is going to fold down to make that end, but then I'm going to have this one here overlapping on the top, and it's not going to be an open topped one. So B is not correct. C, this is going to fold up to here, this is going to fold up to here, and these guys are going to come round like that. Happy days, open top box. Lovely job. And same again for D. This is going to fold up to here. This is going to come round here, and these guys on the side are going to come up here, and this is going to come up here too. So D is going to work as well. Lovely. And that concludes our work on shape. Hopefully that's been really useful this week. Let me know if there's anything that you are unsure of. Let me know if there's anything else you need any further help with. I will do what I can to help. Cheers.